Hello guys, welcome to Makaut CSE-IT and also welcome to our comprehensive guide on database management system or DBMS. In this video, we will explore the fundamental concepts, various database models and the intricate process of database design. We will also dive into the SQL operations, database security, transaction processing, the advanced topics like big data and distributed systems, and emerging trends in the field. Whether you are a beginner or looking to deepen your understanding, the video has something for everyone. Let's embark on this journey to master the essentials of database management system or DBMS. So at first we need to learn about the DBMS. So introduction to database management system. Database management system is a software that provides an efficient and convenient way to store, retrieve and manage the data in database. It serves as an intermediary between the end users and the database, ensuring that the data is consistently organized and remains easily accessible. Now we need to learn about what is database. So a database is an organized collection of data that is stored and accessed electronically. Databases are designed to manage, store and retrieve the large amounts of data efficiently. They can handle a variety of data types such as text, numbers, images and more, making them crucial for various applications in business, science and technology. So in the modern computer science applications, we have various types of databases like relational databases, NoSQL databases, hierarchical databases and network databases. For this video, we will just learn about the relational databases, and the function of databases like data storage, data retrieval, data update, data deletion, data integrity and data security. And data integrity means it ensures the accuracy and consistency of data. So now it is time to discuss about the database system architecture. The architecture of a database management system is designed to handle data storage, retrieval and management in a structured and efficient manner. So understanding the architecture helps in grasping how a DBMS functions and interacts with users and applications. The architecture can be broadly categorized into three levels. The first, three-level architecture, like internal level, conceptual level and external level. Internal level means also known as physical level. It defines how data is physically stored on the storage medium. It deals with the storage structures, indexing and access methods. Components like storage engine, indexing, physical storage. Number two, conceptual level. It is also known as logical level. It defines what data is stored in the database and the relationship among those data. It is independent of how data is stored physically. The components like database schema, integrity constants and views. Number three, external level. It is also known as view level. It is the highest level of abstraction that describes how individual users interact with the database. It consists of multiple user views. Like when we open an app, we actually view some pages. So its component like user interfaces, application programs and external views. So two-tier and three-tier architectures. Two-tier architecture. In this architecture, the client directly communicates with the database server and the client handles the user interface and business logic, while the server manages the data storage and retrieval. So here components like client and server. The three-tier architecture. It adds an additional layer between client and database server. This middle tier, often referred as the application server, it handles the business logic and data processing. So in this case, we have components like client, application server and database server. So now it is time to discuss about the DBMS components like storage manager, query processor, transaction manager, metadata manager. So now it is time to discuss about the database models in DBMS. A database model defines the logical structure and the design of a database, dictating how data is stored, organized and manipulated. Different database models cater to different types of data and application requirements. So the primary types of database models used in DBMS system like hierarchical models and relational model, network model, object oriented model and NoSQL model and various type of is there. So we will discuss each topic. Like first is hierarchical model. The hierarchical model organizes the data in three like structure with a single root from which all other data branches out. So each child node has only one parent, but a parent have multiple child nodes. So its use cases like organizational charts and file systems. Okay, so a company database is where an employee belongs to a specific department. So we can treat employee as a child and a specific department as a parent. Okay, so network model. The network model is similar to the hierarchical model, but it allows each child to have multiple parents, forming a graph structure. Okay, so use cases like telecommunication network, transport network, so university databases where a course can be part of multiple departments. Okay, so relational model. The relational model uses tables to represent data and their relationships, and our DBMS actually concerned in this model. Okay, so each table consists of rows and columns. Use cases like general purpose applications, business applications. So a customer database with tables for customer, order and products. So this is the example of relational database model where we deal with tables. Okay, number 4, object oriented model. The object oriented model integrates databases with capabilities with object oriented programming principles. Data is stored in objects similar to how data and methods are encapsulated in objects in programming. Use cases like CAD, CAM applications, multimedia applications. Examples is like a graphic applications database where the images, shapes, colors are stored as objects with associated method. Okay. Number 5, NoSQL model. NoSQL databases are designed for distributed data stores with flexible data models. They handle unstructured, semi-structured and large-scale data. So here we will see the key value pairs. Okay, so each key have multiple values. So real-time web applications, big data applications and social networks are the use cases. And we can say an example like an e-commerce application where product details, user profiles and transactions are stored in a flexible and scalable manner. Okay, so different database models provide different ways of organizing and managing data, each of its strengths and suited use cases. Understanding these models helps in selecting the right database architecture to meet specific application requirements and data management needs. Okay, so now it is time to discuss about the entity relationship model in DBMS. The entity relationship model is a conceptual framework used to describe the data elements and relationship within a database. It helps in visualizing and designing the structure of a database system. The ER model consists of 3 main components: entities, attributes and relationships. So entities means what? Entities represent the real world objects or concepts that have the properties or attributes. In real world, like a student, a human, or like a cat, dog, like animals. Okay, so real world objects, we can say the entities which have some specific attributes. In the ER model, entities are typically depicted as rectangles. Example like customer, product, employee. So these are the entities. Number 2, attributes. Attributes are the properties or characteristics of the entities that describe them. Each entity has one or more attributes associated with it. Attributes represent as oval, connected to their respective entities. Examples of attribute like customer ID, customer name, address, phone, product ID, product name. Okay, so number 3, relationship. So relationship define the connection or association between the entities. They describe how entities interact with each other. Relationship can have cardinality, means how many, and arity, like degree, constraints. Okay, the type of relationships like one to one, one to many and many to many, and many to one also. So one to one means an instance of one entity, means an instance of a, you can say a student is associated with exactly one instance of another entity. Okay, so this is called one to one. So one to many means an instance of one entity is associated with 0 or more instances of another entity. Means you can say we have a class and we have multiple objects of this class, so these objects are known as instances of the classes. Okay, so in a student class we have various type of student 1, student 2, these are the instances. So these instances have their own properties of a student class. Okay, so many to one means multiple instances of one entity are associated with only one instance of another entity. Many to many, multiple instances of one entity are associated with multiple instances of another entity. So example of relationship like customer places order means one to many, means one customer can places many order. Order contains product, it is many to many. Okay, so cardinality and participation constants like cardinality describes the maximum number of instances of one entity that can be associated with a single instance of another entity. Participation constant like describe whether the existence of an entity depends on its relationship with another entity. Okay, so now it is time to discuss about the ER diagram. An ER diagram visually represents the entities, attributes, the relationships in a database management system. It uses the standardized symbols to depict the components of the models. So here you can see some ER diagram symbols. Okay, so the ER model provides a clear and visual representation of the structure of a database, including the entities, attributes and relationships. It serves as a foundation for database design, allowing databases developers to understand and communicate with the data requirements of an application effectively. So now it is time to discuss about the relational model in DBMS. The relational model is a framework for managing and organizing the data using relations, which are essentially tables composed of rows and columns. This model is the foundation of the relational database and provides a systematic approach for defining and manipulating the data. Okay, so some key concepts related to relational model like tables. It is also known as relations. So a table is a relational database, is a collection of related data entries and consists of rows and columns. Structure is like rows. Rows also we can say that tuples. Each row represents a single record in the table. And column also named as attributes. Each column represents a specific field within the table. Here field means columns. Okay. The schema of a table define its structure, including the table's name, columns and their data types. So now it is time to discuss about keys and constants in DBMS. So keys and constants are essential components of database management system that ensures the data integrity, enforce the relationships between the tables and maintain the accuracy and consistency of the data stored in the database. At first, keys in DBMS. At first, primary key. A primary key is a unique identifier for each record in a table. It ensures that each row is unique and can be used to identify the records unambiguously. Okay, so some characteristic like it must contain the unique values, it cannot contain null values. Okay, so each table can have only one primary key. Okay, so for example, for employee information, the employee ID can be a primary key. For a student ID can be a primary key. So it depends on the data stored in the database. Okay, so it depends on entity to entity. So foreign key. A foreign key is a column or set of columns in one table that refers to the primary key of another table. It establishes a link between the two tables. Okay, so foreign key means one table the foreign key is primary key and another table it acts as a foreign key, means it references from the parent table. Okay, it maintains the referential integrity between two tables. Okay, so candidate key. A candidate key is a column or set of columns that can be uniquely identify any database record without referring to any other data. Each table can have multiple candidate key, but primary key is always one. So we can say that from this statement that every candidate key is not a primary key, but every primary key is already in candidate key. Okay, because we say that candidate key must contain unique values but cannot contain null values. Any candidate key can be chosen as a primary key. So it depends to data. Okay. So alternative key. An alternative key is any candidate key that is not chosen to be primary key. Means candidate key is a set of elements. So one is from this set, one is primary key and others is alternative keys. Okay. So composite key. Composite key is a primary key composed of two or more columns. Means association. Means one key means primary key is associated with multiple columns or others columns in the data. So we can construct composite key. Okay. So combine columns uniquely to identify the each row. So this time to discuss about the constraints in DBMS. So not null constant. It ensures that column cannot have null values. Okay. So unique constant. It ensures that the all values in a column or set of columns are unique. The primary key constant. It uniquely identifies each record in a table. And foreign key constant. It ensures the referential integrity by linking the columns in one table to the primary key of another table. Check constant. It ensures that all values in a column satisfy the specific condition. Default constant. It assigns a default value to a column if no value is specified. So keys and constant are fundamental components of a DBMS that ensures the data integrity, maintain the relationship and enforce the rules on data. So understanding how to use them effectively is crucial for designing the robust and reliable database management system. Okay, so now it is time to discuss about the functional dependency and Armstrong axioms and normalization in DBMS. So functional dependencies are constraints that describe the relationship between the attributes in a relational database. Armstrong axioms are the set of rules used to infer all the functional dependencies on a relational database. So we need to understand about the functional dependencies and Armstrong axiom. At first, the property of reflexivity, or we can say the trivial functional dependency. Okay. So here in this screen you can see the reflexivity, augmentation, transitivity. Okay, so additional inference rules like union, decomposition, pseudo transitivity. Okay, so these are the rules. And the partial dependency, okay, the transitive dependency, and how to find the closure of any attribute and how to find the candidate keys. Okay, so now we need to learn about the normalization. So normalization is a process used to organize a database into tables and columns to minimize the redundancy and dependency. The primary goal is to divide the large tables into smaller related tables and link them using the relationships. At first, normal forms like fast normal form. A table is in 1NF if it only contains the atomic values and each column contains a unique value. Here atomic means indivisible. So now the second normal form actually removes the partial dependency. So actually what is partial dependency? So partial dependency says that the proper subset of a candidate key determine the non-prime attribute. Okay, so here we need to learn about the prime and non-prime attribute. Like actually for construct candidate keys, the elements of candidate key is the prime attribute and others element which is not associated with candidate key, these are called non-prime attribute. Like if our table has attribute like A, B, C, D, E and our candidate key is A and E, so others attributes actually non-prime attributes and A and E are prime attributes because they construct candidate key. Okay, so a table is in 2NF if it is in 1NF and all non-key attributes are fully functionally depend on the primary key. So now the third normal form, a table is in 3NF if it is in 2NF and all the attributes are functionally depend on only the primary key. It means 3NF removes the transitive dependency also. It means no transitive dependency for non-prime attribute. A table is in 3NF if and only if for two conditions each of them can be satisfied. Okay, at first left hand side is super key or right hand side is prime attribute. So any of them will satisfy for actually concluding the 3NF or third normal form of a table. So BCNF or Boyce-Codd normal form. In BCNF, it should be in 3NF, and for every functional dependency the left hand side is super key. So BCNF is the most restricted version of third normal form. Okay, the fourth normal form or higher normal forms, like a table is in 4NF if it is in BCNF and has no multi-value dependency, means one attribute actually depends on the multiple types of attributes. So multi-value dependency is there. Okay, so fifth normal form, table is in fifth NF if it is in 4NF and cannot have any joint dependency, which cannot be expressed in terms of the candidate keys of the relation. So, the functional dependency and normalization are fundamental concepts in database design that helps to ensure the data integrity and reduce the redundancy. Armstrong axioms provide a basis for reasoning about the functional dependencies, while normalization transforms a database into a series of related tables that adhere to specific normal forms, improving its structure and efficiency. Okay, so now it is time to discuss about the SQL and database operations in DBMS. So, the structured query language is a standard language for managing and manipulating the relational databases. It provides the common commands for defining, manipulating, querying, and controlling the access to data. SQL operations can be broadly categorized into data definition language, data manipulation language, data query language, and data control language and transaction control language. Okay. So at first, the data definition language, or DDL. DDL commands are used to define and manage the database schemas, objects such as tables, indexes, and views. So some common DDL command like create, it actually creates some new tables, view, index, or other database object. Alter, it modifies an existing database objects. And drop, it delete an existing database object. Truncate, it removes all the records from a table but does not delete the table. That's the difference between drop and truncate. Okay, so data manipulation language, DMLE command are used to manipulate the data stored in the database objects like insert, update, okay, delete. Data query language, or DQL commands are used to query the database for information retrieval like select, okay, advanced select features like joins, where clause, group by, having clause, order by. Okay, so the join has three types like natural join, okay, full outer join, inner join, outer join. Okay, so data control language, DCL commands are used to control the access to the database, okay, like grant, revoke. Transaction query language or transaction control language, TCL commands are used to manage the transaction in database, ensuring the data integrity and consistency like commit, rollback, save point, release save point. Okay, so now it is time to discuss about the storage strategies in DBMS. The storage strategies in DBMS are crucial or critical for efficient managing, storing and retrieving and manipulating or maintaining the data. Proper storage strategies ensure the optimal performance, scalability and reliability of the database system. The main storage strategies in DBMS include the data storage and organizations like row oriented storage and column oriented storage. Row oriented means OLTP, okay, online transaction processing, and column oriented means online analytical processing, stores data column by column, which is efficient for analytical operations. File organizations, heap file, sequential file, hash file, clustered file. Heap files mean unordered storage where new records are placed wherever there is a free space suitable for small databases and infrequent queries. Sequential files, okay, records are stored sequentially based on the sorting key. Hash files, records are placed based on hash function. And clustered means related records from different tables are stored together to improve the join performance. Indexing, primary index, secondary index, clustered index and non-clustered index. Okay, so primary index here means an index on the primary key of a table ensures that the primary key values are unique and sorted. Secondary key, an index on the non-key columns to speed up queries involving those columns. Clustered index means determine the physical order of the data in a table based on the indexed column. Okay, partitioning means horizontal and vertical partitioning, data compression, lossless and lossy compression. Okay, so the storage management like block storage, file storage, object storage is there. So effective storage strategies in DBMS are essential for optimizing the performance, and also the multi-level storage strategy like B tree, B plus tree. Okay, this is the advanced version of binary search tree. Okay, so now it is time to discuss about the transactions and concurrency control in DBMS. A transaction is a database management system. It's a sequence of operations performed as a single logical unit of work, like a payment transaction when you can send amount to someone in a apps. Okay, at that point of time, the DBMS transaction and concurrency control occurs. A transaction must exhibit 4 key properties known as ACID properties: A for atomicity, C for consistency, I for isolation, and D for durability. Atomicity: it ensures that all operations within a transaction are completed successfully. If any operation fails, the entire transaction is rolled back, leaving the database in its original state. Consistency: it ensures that a transaction takes a database from one valid state to another valid state, maintaining the database integrity. Isolation means ensures the operations of transaction are isolated from other transactions until the transaction is completed. This prevents the transaction from interfering with each other. Durability: it ensures that once a transaction has committed, it will remain so, even in the event of system failure. Okay, so the transaction states like active state, partially committed, failed, and aborted. Okay, so these are the transition diagram of transaction process. Okay, so some concurrency control in DBMS means the concurrency control is the management of simultaneous operations on the database without interfacing with each other. It ensures the correctness and consistency of data when multiple users access the database concurrently. So concurrency control techniques means log-based protocol, shared log, exclusive log, two-phase locking, growing phase and shrinking phase, and timestamp based protocol. Okay, so each transaction is assigned a unique timestamp. Optimal concurrency technique like validation phase, multi-version concurrency control. Okay, so now it is time to discuss about the advanced topic in DBMS. Advanced topic means like distributed database, where the data is stored across the multiple locations. Here transparency, replication, scalability occurs. So types of distributed like homogeneous, heterogeneous. Okay, so NoSQL databases where data can store in unstructured, semi-structured format. Okay, it's not like table format, it is like key value pairs. Okay, so use cases like big data applications. Okay, database security like authentication, authorization, encryption to verify the identity of users. Okay, so big data management like volume, velocity, variety, veracity. Technologies like Hadoop and Spark, Apache Kafka is used for that purpose. Okay, so data warehouse and OLAP like purpose like ETL processes, extract, transformation, and load the processes for analytical purpose. Schema design. Okay, thanks for joining us this amazing video, or thanks for watching, and also subscribe our channel for more videos.